Okay, guys, welcome. Today we're going to talk about solving equations and inequalities with fractions or with rational expressions even. Okay, now we've spent a lot of time talking about how to manipulate by simplification, by adding and subtracting, multiplying, dividing rational expressions and fractions altogether. All right, but as soon as you have an equation or an inequality, you've unlocked a power that you can now use that you weren't able to before. All right. And that's that you can multiply both sides of an equation or an inequality by something. All right. So that's sort of the basis in this. Right. So if you have an equation with fractions, the first thing you're going to do is you're going to find the LCD. Right. Once you have the LCD, you're going to multiply both sides of that equation by the LCD. And then what's going to happen is you're going to be left with something that doesn't have any fractions anymore. All right. Then you have an equation or an inequality that you can solve as we did before. And then the only thing that you need to do at the end is just check that any answers that you found, this is very important, won't cause any division by zero in the original problem. All right. So if you come up with an answer that doesn't satisfy the original equation, whether it causes division by zero or if it makes the equation wrong, then you would need to throw out that answer. Okay, so let's do a couple of examples of that. So in part A, we have 8x plus 1 over x minus 2 plus 4 is equal to 7x plus 3 over x minus 2. Well, here, hopefully it's easy to see that the LCD is simply just x minus 2. So that's what we're going to multiply both sides of this equation by. Now, when you distribute this here, I'm going to do this in slow motion the first time, right? You're going to get 8x plus 1 times x minus 2, right? If you think of this as x minus 2 over 1, all over x minus 2. And then plus 4 times x minus 2 is equal to 7x plus 3 times x minus 2 over x minus 2. Now remember, the whole idea of multiplying by this LCD was to get rid of fractions, right? And of course, once you perform these cancellations, that's of course true. You now have 8x plus 1, and then once we distribute 4x minus 8 is equal to 7x plus 3. And of course, this equation doesn't have fractions anymore, which is good. So now if we combine like terms, we get a 12x minus 7 equals 7x plus 3. If I move all my x terms to one side and add the 7 over, I'm going to get that 5x is equal to 10, which leaves me with x is equal to 2. All right, but now we need a check in the original. Now, of course, you run into a problem right away, because if you go and you plug this into the original, right? So for example, if you go to plug it into this part right here, you're going to get 17 over 0. And then you're going to get a 17 over 0 again, right? So as soon as you have division by 0, this is not good. Right? So you have to throw out x equals 2. This is no longer an answer. And of course, since you're left with nothing else, this is no solution. All right, so that's one thing you have to be careful of now. Okay, now part B, we have 3 over x minus 1. And that equals 1/2 minus 6 over x. Let me just make sure I got that right. 3 over x minus 1, 1/2 minus 6 over x. Okay, cool. So in this case, our LCD, again, hopefully it's not hard to see, is that this is a 2x. So when I multiply both sides by 2x, I'm going to be left with a 6 minus 2x is equal to an x minus 12. Okay, so when we solve, I'll bring my 2x over here, and my 12 over here, and I'll get 18 is equal to a 3x, so x is equal to 6. Okay, now if we check this, I'm going to get a 3 over 6 minus 1 is equal to a 1/2 minus 6 over 6. Well, as soon as you simplify these fractions, this is 1/2, and this is 1. So you get the left-hand side and the right-hand side are the same, so that's good. So this is the solution. Okay, part C, let me give myself a little more room. So for part C, we have negative 2x over x plus 1. And equals 1 plus 2 over x. Was that plus 1 or minus 1? Plus 1 still, okay. Okay, so again, in this case, the LCD is the only denominator we have. It's just x plus 1. So now when we multiply, my x plus 1's cancel, and I get a negative 2x on the left side. And then I get an x plus 1 plus 2 on the right side. So this is going to become negative 2x is equal to an x plus 3. So then if I, let's see, so if I subtract this x, I get negative 3x is equal to 3. So my x is negative 1. And of course, if we check, I'm going to get a 3 over negative 1 minus 1. Wait, am I looking at the right one? No, I'm not. Okay, so if we check this, I'm going to get a positive 2, right? Negative 2 times negative 1 is a 2 over a 0 again. So that's no good. So as soon as I see that, I know I can throw this answer out, and we get no solution. Okay, so that's no solution. Okay, so solving inequalities works exactly the same way. We just have to solve the inequality that remains. So just keep in mind the different rules for solving an inequality. For example, if you multiply or divide both sides by negative, you have to be careful that you flip the sign there. Okay. Okay, so let's look at a couple of examples. So in part A, we have x over 2 minus 9 is less than 1 minus 2x over 3. So in this case, our LCD is 6. If we multiply both sides by 6, we're going to get a 3x minus 54 is less than a 2, and then a parentheses 1 minus 2x. Okay, so now if we simplify the right side, if we distribute, we're going to get a 2 minus 4x. So if I add 4x and add 54, I'm going to get that 7x is less than 56. So once we divide, we're going to get x is less than 8. Okay, and since my LCD was a positive number, I don't have to worry about sort of checking any of this stuff as long as I don't have division by 0 or anything. Okay, part B, we have a 3x minus 1 over 4 plus 1 is less than 2 plus x over 3. So here, my LCD, I have 3 and a 4, so the LCD is 12. So we're going to multiply both sides by 12. So if we do that, we're going to end up with a 3 times parentheses 3x minus 1 plus 12. And that's greater than 24 plus a 4x. So if we distribute, we get a 9x minus 3 plus 12 is greater than 24 plus 4x. So this becomes a 9x plus 9 greater than 24 plus 4x. So we'll go ahead and we'll move the 4x over, move the 9 over, and we get a 5x greater than 15. So we get that x is greater than 3. Okay, finally, part C, we have a 2 plus 3x over 5 minus 1 is less than or equal to x plus 1 over 3. Okay, so now it looks like our LCD here is a 15. Sorry. Oh, no. Yeah, that's fine. So then I'm going to end up with a 3 times a 2 plus 3x minus 15 less than or equal to 5 times x plus 1 once we cancel. So if we distribute, we'll then have a 6x, sorry, just a 6 plus 9x minus 15 less than or equal to 5x plus 5. So when we combine like terms, we're going to get a 9x, let's see, minus 9 is less than or equal to 5x plus 5. So if we subtract 5x and add 9, we're going to get that 4x is less than or equal to 14. So we get that x is less than or equal to 14 over 4, which is 7 over 2. Okay, so that is our final answer there. Okay. Okay, I think these are, yeah, the last 2 examples. Okay, so let's do these last 2, and then that will conclude this video. So we have a 2 times an x plus 1 over 3 less than 2x over 3 minus 1 over 6. So here it looks like my LCD is just 6. So if we multiply both sides by 6, I'm going to get that this cancels with this, and I'll be left with another 2. So we get a 4 times x plus 1. And then here I'm going to get a, when I distribute it here, 6 divided by 3 will be 2 times another 2 is 4x. And then 6 times 1, 6 is just 1. So I'm going to get a 4x plus 4 less than 4x minus 1. Now when we go to subtract our 4x's, we get that 4 is less than negative 1. Right? Now this is not true. So this, of course, is no solution. All right, so that is one thing that can still happen here. Okay, part B, we have a 2x minus 3 over 2 greater than or equal to x plus 2 over 5. So our LCD here is going to be 10. So when we multiply, we're going to get a 5 left over times the 2x minus 3 greater than or equal to 10x. And then 10 divided by 5 is 2, so we're going to get a plus 4. So it looks like we're going to get a 10x minus 15 greater than or equal to 10x plus 4. Looks like a similar situation is going to happen, because now once we cancel the 10x from both sides, we're going to get negative 15 greater than or equal to 4, which of course again is not true. So this is no solution again. Okay, so that concludes this video on solving equations and inequalities with fractions or with rational expressions. I hope you enjoyed, and I will see you next time.